As mentioned earlier, Booleans are simply true and false values. As such, there's not much more to really say about them than that. What's more important is how you can get them and what you can do with them. First, let me introduce you to a group of operators that lets you compare two values. These will all return a true or false value. First is the equals operator. 5 equals 5 is true. 5 equals 6 is false. Note that this is a double equal sign so that it's different from the single equals assignment operator. And then there's the not equals operator. 5 not equals 6 is true. 5 not equals 5 is false. Then there are greater than and less than operators. 6 greater than 5 is true, 5 less than 4 is false. And you can combine those with equals so that 5 greater than or equal to 5 is true. You can also use any of those to compare strings. So, a rose is a rose. If two strings contain the same text, they'll be equal. If they have different text, they won't be equal. So a cat is not a dog. But what about the other comparison operators with strings? Is a cat greater than a dog? Well, there you go, dog lovers, you were right all along. Actually, what's going on here is an alphabetical comparison. D comes after C in the alphabet, so the string dog is greater than the string cat. But be careful, the way characters are coded in JavaScript, all capital letters actually come before all the lowercase letters, so a lowercase cat is actually greater than an uppercase dog. And of course, true equals true, false equals false, but true does not equal false. So now you can compare two values and see whether or not they're equal, and get a Boolean value from that. But what can you do with it? Well, here's where we actually start to get into some real programming. Enter the if statement. Computers are great at storing data. We've seen that with variables. And they're great at processing data, as we've seen with all the various calculations you can do with numbers. Another thing they're really good at doing is analyzing and acting on that data. If you enter your username and password correctly, the system lets you onto the site. Otherwise, it locks you out. It analyzed the data you entered and either accepted or rejected it, and acted accordingly. A lot of that is accomplished with the if statement. The way an if statement works is like this. You say if, followed by a pair of parentheses, with some value or variable or some expression inside them. This is followed by open and close brackets. Inside those brackets is some more code. So if the thing in the parentheses evaluates to true, then the code in the brackets will run. If it evaluates to false, that inner code will be skipped. To demonstrate this, I'll jump back into the code editor because this is going to be more than a simple one-liner. Now this is the same HTML file we had before. It simply has a script tag that loads a file called main.js. Right now, main.js has nothing in it. Now a stupidly simple example is simply saying if true. Now of course true will always evaluate to true, so that console log statement will always run. A more realistic example would be to have a username passed in from some HTML text field. I'll simulate that with a variable for now. Now of course real login code for a real site would be a bit more involved in that, but somewhere in there I guarantee you that there's an if statement not unlike this. As it's written, you'll get into that if statement and the console log statement will run. If you change the value of username, that code will not execute. You can use the if statement with numbers in comparisons as well. So if I set age to 35 and min age to 18, and then compare the two with greater than or equals, because age is greater than min age, you get in. Now you might be thinking, what if age is less than min age? You could make another if statement saying exactly that. But there's an easier way, using an else statement. The else statement looks like this. So we have a block of code after the if, then an else, and then another block of code. One or the other of those two blocks will always run. If the if condition is true, the first block will run and the second won't. If the if results in false, then only the second block will run. So in the code, you can change the second if statement into an else statement. So if age is greater than or equal to min age, you get in, else you don't. Using this, you can make a very sophisticated decision maker. First, we'll generate a random number and compare it to 0.5. The random number will have a 50% chance of being above 0.5 and 50% chance of being below. So roughly half the time the first block of code will run, and half the time the second one will. ask it a question, refresh the page, and get some good solid advice. Should I sleep in today? Okay. Should I handle my email inbox today? Not sure I like this program. There needs to be more options. Well, there is an else if statement line you can throw in there. This looks like this, and it works just about how you would expect it to. If this, do this. Else, if that, do that. Else, do the other. So let's add a maybe clause to the decision maker. Here I'm breaking down that random number into 3 roughly equal chunks. If it's greater than 0.66, you get the first option. Else, if it's greater than 0.33, you get the second. Else, it must be less than 0.33, so you get the third choice, maybe. You can actually throw as many else if blocks in there as you want. You can then finish it up with a single else block or just leave that off. With this structure alone, you can create all kinds of complex logic. Now, the last thing I want to mention here is a concept called type coercion. This means that if JavaScript is expecting a certain type of data and gets a different type, it will try to coerce or convert what it got into what it needs. This can be really useful in if statements. A common use for this is dealing with undefined or null variables. As you saw in the last video, trying to do things with undefined variables can result in errors. You can get similar errors trying to use null values. So if there's any chance that a variable might be undefined or null, it's good to check it before using it. Say you have a shopping cart application, and there's a cost variable, which is $10 or whatever, and a quantity variable, which is not yet set. You'll be multiplying cost by quantity to get a total. But if quantity is never set, you'll be in trouble. So before you do the multiplication, you can check to make sure that quantity is not undefined. If that's the case, you can safely calculate the total. Else, you can display an error. But there's a shortcut you can use here. Just say if quantity. The if statement is expecting a Boolean value, true or false, but instead it gets either a number or undefined. If it gets a number other than 0, it will coerce this into true, and the first part of the if statement will execute. If it gets a 0 or undefined, this will be coerced into false, and the error will be displayed. Now, when we run this, we get an error because quantity is undefined. If we set quantity to a number like 2, the result is 20. So, what gets coerced into what? Well, there's a list of rules, but once you get them, they're pretty logical and easy to remember. Undefined and null get coerced into false. For numbers, 0 is coerced into false. Any other number is coerced into true, including negative numbers. Any number other than 0 is true. Strings are just as easy. An empty string would be 2 quotes with nothing in between them. This is coerced into false. Any other string is coerced into true. A tricky one is the string false. This feels like it should become false, but it's a non-empty string, so it does in fact get coerced into true. And there's one more connection I want to show you about comparisons and coercion. You've already used the double equals operator to check if 2 values are equal, like so, 5 equals 5. This, of course, is true. But try 5 equals the string 5. You also get true. So here we have a number being called equal to a string. There are 2 different types of data, but JavaScript will try to coerce that string into a number. Because the string only contains a number, it does successfully coerce it into the number 5, which is equal to the original 5. Now, generally speaking, if you have 2 different data types, you wouldn't really expect them to be equal. This is considered by many to be an odd quirk in JavaScript. Some might even call it a bug. To get around this, there's another comparison operator, the triple equal sign or strict comparison operator. When you use this, it does not do any coercion. So 5 equals the string 5 results in false. The double equals comparison has additional odd behaviors when comparing other data types. So most developers consider it a best practice to always use the strict version. I'll be doing that for the rest of this course, so if you see a triple equals, you'll know what's going on. Okay, that's a lot to take in, so take a break, try out some other examples in the console or in a JavaScript file, and when you're ready, come back and we'll learn all about strings.